Imagine that you're writing a research paper. You have more or less completed the methodology and experimental results, but now you have to start working the introduction and related work sections. Normally, this process will require you to carefully read a bunch of papers to find the claims and facts that are related to your work. QuoTeS is a query-focused summarization system designed to help you in this task. It takes as input the abstract of your upcoming article and some papers that you think may contain relevant passages, and gives you back the papers with highlights that indicate the sentences that are related to your query. In this setting, a sentence is considered relevant if it shows that the document it came from and the query are related. The purpose of QuoTeS is not to give you a fully automatic summary, because it would be really bad if you miss something important from your papers, but instead it gives you some pointers about what sections to read more carefully. The way that QuoTeS works is the following. First, it extracts the text from your documents and splits it into sentences. Then, uses your query and the sentences that you have already marked as relevant to train a recommendation system based on techniques from machine learning and natural language processing that helps you find more sentences related to your query. In the end, you end up with a bunch of sentences that make up what is called the query-focused summary of your collection, which hopefully will make your writing task easier. QuoTeS is designed to work with several papers, each one with hundreds of sentences. Once in the QuoTeS website, you can upload one paper at a time using the upload and add buttons. You can upload PDF, plain text, and JSON files. Once you're done uploading, click on Process Documents to get the system ready. This takes a bit. You can tune how the system works in the settings. In the Embeddings menu, you can select how the system represents the query and the documents. Word unigrams are very simple and fast to compute, but they also require the exact matches while searching. Character trigrams are somewhat more complex and take more time than word unigrams, but they are also more flexible, being capable of finding the similarity between words. And finally, sentence-breadth embeddings are the most sophisticated and slowest representation to compute, but they allow the system to understand the meaning of words and whole sentences. In the classifier menu, you can choose which machine learning algorithm to use as backbone for the system. Logistic regression is very fast, but it is somewhat rigid in the kind of relationships it can model. Random forest is slower than logistic regression, but it is well suited to work with word unigrams and character trigrams. The last option, support vector machine, is the slowest one, but it is also the one that works the best with sentence-breadth embeddings. If you are unsure about what options to use, just leave them at the defaults and play around with your documents. You can always come back to the settings and change them. In the Documents tab, you can browse the text extracted from your papers. The sentences from your papers are shown in the order they were found, so that you can verify that everything was uploaded correctly. The Search tab is the first main component of the system. In the text box, you can write what you're looking for, and after clicking on Search, the system will try to retrieve the most relevant sentences using traditional methods from natural language processing and information retrieval. The system works well while searching for specific words and phrases, but where it shines is when you use longer queries, like abstracts from papers. As an example, let's use the abstract from BERT to find the citation it had in these papers. The sentences that appear below are the best matches according to your query and the representation you picked. You can label them as relevant or irrelevant by clicking on them, but the system will only record them once you click on Submit Labels. The Explore tab is the second main component of the system. What this tab does is to train the system using the labels you have submitted to better understand your search. The plots show the distribution of the recommendation score and how it breaks down by document to help you better understand your collection. The sentences below work exactly like in search, allowing you to label them and submit them into the system. You can label the collection as much as you want, but the recommended criterion to know when to stop is when the system hasn't recommended anything relevant in 3 consecutive turns. In the History tab, you can see what you have labeled so far and where to find it in the papers. Like before, you can click on a sentence to relabel it if you want. You can also clear the history you have created or download it as a CSV file. The last tab is Results. The plots in the top show the level counts and how they break down by document, while the bottom part displays the query and the sentences that were marked as relevant. The query along these sentences make up the final output of the system, which is the query-focused summary of your collection. You can download this summary as plain text or the full state of the system as a JSON file to keep analyzing it in the future. If you are participating in the user study of QuoTeS, this JSON is what you need to keep moving forward.